All right, welcome back to another video of our last unit of the school year. Hi, hello. All right, so we're going to go ahead and start talking about nature of energy. So here we go. All right, so energy is the ability to cause change. It's measured in joules, which is someone's last name, so that J needs to be capitalized. So it's a capitalized J as the short version. 1 joule is equal to 1 kilogram per meter squared per second squared. There are many different types of energy, but we're going to start talking about kinetic and potential energy. So kinetic energy is KE, it's energy in motion. So you can actually calculate it by doing 1/2 mv squared, where m is your mass, which is measured in kilograms, and velocity is your v, which is measured in meters per second. So the easiest way to think about this kinetic energy is energy in motion. So here I put a picture of a surfer. This is energy in motion. He has kinetic energy because he is dropped into the wave. He's riding that wave until the rip curl catches him pretty much. So example number 1, a jogger with a mass of 60 kilograms is moving at a speed of 3.0 meters per second. What is a jogger's kinetic energy? So we are looking for kinetic energy. His mass is 60 kilograms. His velocity is 3.0 meters per second. We're going to use our original equation here. So we're going to do 1/2 times 60 times 3 squared. Order of operations tells us to do the squared first. So squared of 3 is 9, and then half of 60 is 30. So 30 times 9 is 270 joules for our kinetic energy. Now I'm going to go ahead and have you practice this. Here are 3 different examples. Do your best, come back, and I will have the answers for you. All right, here's the answers for 1, 2, and 3. All right, so here is potential energy. Potential energy is stored energy. I call it the potential to have energy, but it's just stored energy. There are 3 different types. There's elastic potential energy, chemical potential energy, and gravitational potential energy, and we will talk about each of those in turn. So let's go ahead and talk about potential energy first. So potential energy is the energy that's stored in objects being compressed or stretched. So things like your bow and arrow, if you're a bow and arrow hunter, a spring like a slinky, or even a slingshot if you know how to use a slingshot. Those are all examples of elastic potential energy. The next type is our chemical potential energy. That is an energy that's stored in chemical bonds of compounds. So for example, firewood, there's chemical potential energy. Batteries, they're chemical potential energy. The food you eat has chemical potential energy. That's how you get your energy, is the breaking of chemical bonds. Let's go ahead and talk about potential energy of the gravitational type. So the gravitational potential energy is GPE. It's energy stored in objects that are above Earth's surface. So this is for anything that has to do with gravity at all. Gravitational potential energy is HAM, GPE equals ham. So H is height, which is measured in meters. Acceleration, which is due to gravity, it's measured in meters per second squared, and then your mass, which is measured in kilograms. So right here I have an example of a Newton's cradle. At the peak of its path, the sphere pauses for just a second, has a gravitational potential energy before it converts back to kinetic energy as it moves towards the spheres. So it's got gravitational potential energy right here. All right, here's example number 2. So how much gravitational potential energy does a 5 kilogram rock have if it is sitting on the edge of a cliff that is 10 meters high? So our GPE is what we're looking for. Our mass is 5 kilograms. Acceleration of gravity is 9.8 meters per second squared. Our height is 10 meters. So we're going to go ahead and plug it into the normal equation. So 10 times 9.8 times 5 gives me 490 joules. All right, another practice time. So go ahead and pause, try to solve these as best you can. I'll be back with the answers. Okay, so here's the answer for 1, for 2, and for 3. And now we're going to go ahead and spend the time practicing kinetic and potential energy. Let me know if you guys have any questions.